Hi, my name is Tamaya, and today I will be going over the X-ray tube. So just to give a brief today, with the X-ray tube, this is a very important component of being able to just understanding and have the comprehension of the different parts of the X-ray tube. There we have the low voltage side, and then we also have the high voltage side, which I'll get more into that as I go on. But the reason as to why it would be even important for you to understand or even learn what the X-ray tube is if you're looking to be in any type of medical imaging, radiography, being in any type of field as such, it's very important to understand the factors of what consists of the X-ray tube. So today, the first thing that I will be going over will be um, the I'm sorry, the primary side of the X-ray tube, and then I will be going over the filament part of the X-ray tube, and then lastly, I'll be going over the secondary circuit, which all these are important components to the X-ray tube and how it functions all together. So you may wonder what even is an X-ray circuit and why is it even important? So the X-ray circuit is basically a pathway that allows the X-ray circuit to accept current and be able to um, control and modify the power to be able to run through this circuit, to be able to even produce X-rays. It's very important. Um, so with the low voltage side, we have the main switch. So the main switch is going to be the part that's going to allow us to be able to flip that switch on the wall, to be able to allow incoming current to come in through the entire circuit. Now we have many different components that have a lot of different factors in why they run the way that they run. So when we're utilizing the main switch, when we go ahead and turn that switch on, we are allowing that current of 220 volts to come through the current, come through the circuit, allowing us to receive that current to actually process the X-ray machine. So when utilizing it, you may wonder why we even use 220 volts. Why don't we use 330 volts? Well, there's not an actual specific reason as to why we use 220 volts, but it's normally because it's the standardized part of being able to utilize um, the auto transformer and to be able to utilize through the rest of the circuit because there are many other components that happen to utilize boosting it and stepping it up and so forth. Um, so basically today I'll be utilizing, before I get further into the actual circuit, I'll be utilizing 65 kVp, 30 MA, 0 0.3 seconds, which is going to conclude my 9 mass as total. So basically, with the next thing that we have that's important, we have the auto transformer. So the auto transformer is another important part of the X-ray circuit. So it's positioned between the main power and the step-up transformer, and the high voltage transformer. So basically, what this does is that the auto transformer happens to consist of an iron core with single winding. So basically, what that does is that allows the transformer to control the settings of the kVp. As said, I have 65 kVp. So what this does is this allows for the voltage to contain kVp selection and voltage and so forth, and that's when it's flowing through the X-ray circuit. Um, so this also includes self-induction and alternating current. So moving on to the kilovoltage meter, which is here, this is going to be a function that also controls the kVp. But what this does is this is going to be measuring the kilo electron volts, and also measuring the kilo electron volts, and basically affecting the image quality, how it penetrates through the body, the image contrast, and so forth. All of these different things coincide with the kilovolt meter, which again, 65 kVp is my set. So when I'm setting that, we're allowing it to be an energetic X-ray based off of what you're setting your kVp as when you're penetrating through skin, bones, body. So higher KVP can improve um, the penetration, but it also can reduce the contrast within an image. So this is one of the primary factors that determine the quality of a radiographic image. So this also coincides with mass, seconds, milliampere. This is all coincides with the kilovolt meter. So then we have the X-ray. I'm sorry. Then we have up here is what's going to be the exposure switch. So the exposure switch is what's going to allow the current to flow through to be able to actually get that exposure to produce an X-ray image. So when we are using the exposure switch, what happens is we are allowing for a bridge to close, which is when we're pressing that switch, we're holding it, which is allowing us to be able to either start or stop an X-ray. When we let that button go, what we're doing is we're opening the bridge to be able, which is stopping the current. When that current is stopped, we are basically allowing for the when that current is when that current's closed, the currents are being able to flow through to actually produce the need be exposure. So when that current opens is when that is when that switch is no longer connected and current is no longer flowing through to be able to utilize that exposure. So what happens is it's very important to ensure that when you are holding the exposure switch, that it is held at a good enough duration, so that the exposure is actually complete. Because if the exposure is not complete, what happens is if you let that go and the exposure is not complete, we can be possibly damaging and reducing the life of the actual entire X-ray circuit, which concludes the machine. So this is a very important part. So the switch is what completes the electrical circuit, allowing the high voltage KVP to flow to the X-ray chain. Um, so the X-ray timer is basically determined by also the exposure switch. So the timer is what's going to allow us to be able to know how long the timer is going to be set, so that we know how long that electricity is going to actually flow through to be able to get that exposure. So that actually goes through with the seconds, zero point 0.3 seconds. So this is what is using a capacitor charge that is I'm sorry, a capacitor charge resistor that is allowing us to be able to determine the time for the exposure. So this is a wire that is going to run between the auto transformer as well as the step up transformer. So again, when that exposure button is pressed, the timer is what's going to be allowing us to be able to know how long that current is going to run through to be able to project that exposure. So what happens here for the step up transformer? Um, we're looking at the flow of current to be stepped up eventually to be over to the step up transformer to step it up to the high voltage. So this is low, this is the high voltage. So what happens is that the circuit raises the volts from the 220 volts roughly to up to 10,000 volts. So the main portion of it is to be able to change it to low voltage to high voltage. So this is what's needed to be able to actually get that process to actually producing that image at a high rate to be able to get that heat going to process the X-ray image. So furthermore from there, let's see. Um, Yes. So with this, we also have the cathode and the anode filament, which with the cathode filament, we have it to where this is what is going to be able to allow us to utilize the this is basically what's going to be able to allow us to produce imaging again. And then also, when we are stepping up that transformer, we are going ahead and stepping up that from low voltage to high voltage. So we are completely changing the current flow and how it's alternating through the current to be able to process through the secondary. Now, we will get more into detail about the step up transformer after we touch more base on the filament. So So we're gonna go down here to the filament side of the X-ray tube, which this part is very important. So the filament ammeter is very important because this is what produces the thermionic emission. So what happens is that this is pushed towards the anode to create X-rays. So the main job of the filament circuit is to be able to heat up that tungsten filament um, to be able to basically release the electrons to be able to um, process the thermionic emission. So what happens from there is that we have those positive charges that are accelerated to the positive side of the tube. So we have the mass selector from after the basis of the filament. So what this does is a variable resistor. So this a resistor is what resists current. So when the variable resistor is used, this is what is allowing the mass setting for the X-ray circuit or to produce an image. So what happens is this is what's going to allow us to be able to control the actual function and how much milliampere is going to be included to produce an image. So the variable resistor is what is going to be producing that part of the MA. So when we're including 30 MA, that's where this is taking place at. So the mass selector is what enables the milliampere settings, which is what exactly and controls the tube induction. Um, so from there, we have the step down transformer. Um, so what this does is this is connected to the selector as well as the filament and the step down. So this is an important component of the step down. So the step down is going to be opposite from the step up transformer. So the step down is what's going to be allowing us once we step down the filament, it's basically bringing you back down to the low voltage side. So that is the more fundamental part of the step down transformer, which is also a very important part. So the now so basically the high voltage, the low voltage, and high voltage converts on the side of the tube. So what happens is this is allowing the electrons to form an actual electron cloud um, to basically accelerate these electrons to the anode to produce the actual X-ray of within the X-ray circuit. Um, so this this here now we get to the secondary coil of the step-up transformer. So when we get over to the step-up transformer here, what happens is that this is what's allowing um, the auto transformer of the incoming AC voltage and going ahead and converting this from volts to kilovoltage. So what this is doing is upping the voltage of this so that it can conduct the high heat and the needed current that's needed on the secondary side. So this is what is going to be accelerating the electrons to be able to produce the high coming current that's needed on this side. So from the step up transformer, we have the MA meter. So the MA meter is what's going to be processing the part of the MA, which the MA is what's going to be converting the milliampere to the milliampere meter. So from this area here, sorry about that. So yes. So for the MA meter, we have this is what is going to be after we're processing the step up. This has to be changed to be able to accept the difference within the high voltage to within the low voltage to the high voltage side. So Then this is what is measuring the electric current um, when the mass setting is higher, because the mass setting is a lot higher, and the circuit and the volts are a lot higher on this side. So then we have the rectifiers. So for the rectifiers, we have this on the high voltage side, which what happens here on this side is that the anode is basically the part that's going, I mean, I'm sorry, the rectifiers that are on this side is going to be allowing us to basically control the way that the X-ray is going to be going. So these rectifiers is what's allowing the current to be able to process going through alternating ways. So there's current that'll be going this way, and then there's current going that way, and then vice versa. So they basically meet to be able um, to assist and produce the current that's needed. Um, so let's see. Perfect. Okay. Perfect. Yes. So from there we have the from the rectifier we have the X-ray tube. So once the rectifiers are working as need be to be able to utilize that alternating direct pulsating current, what happens is that this is what's going to conclude completing the actual X-ray here, to be able to project and produce that X-ray through the X-ray tube. Um, so this is what actually is going to conclude the X-ray circuit for the X-ray circuit. Alrighty. So now we have the um, now we happen to have the X-ray tube. Oh, actually, I'm sorry. So I do want to go over the rectifiers one more time. And the MA. So the MA is going to basically be able to again control the mass settings, which is constructing the X-ray photons to be able to give the strength to influde the electrons. Uh-huh. So the rectifiers again is what's going to be allowing us to be able to um, conduct um, the electrons going towards the anode. So yes, again, this is going to be utilizing that alternating current, which is going to be that pulsating current to the X-ray tube. So we have halfway, which is going to be utilizing only on one side, and then we have the DC output as well. And then we also have the full wave rectification, um, which is going to be utilizing both sides of the AC cycle. Uh, so this is actually a very essential part of the X-ray tube, because we want to ensure that this is going to be utilizing the flow of current correctly to go through the X-ray tube. So, alrighty. Yes. So, and then lastly, we have it to where the X-rays conduct the basically to be able to produce the actual X-ray. I just wanted to touch more base on this area. So, lastly, we have the anode and the cathode of the X-ray tube. So, I want to go ahead and explain. The anode target is the positively charged part of the X-ray tube. So, this is the side that is positive. So the electrons move quickly through the anode. So the glass envelope here is what is going to be holding the vacuum and the glass envelope to be able to produce that actual imaging of the X-rays. So then we have the target, which is also going to be utilizing the x-rays that hit up against, which is going to be utilizing the anode Hill effect, which is also an important factor of the x-ray tube. Lastly, we have that rotating portion, which is basically rotating the portion of the X-ray tube to make sure it's dissipating dissipating that heat throughout the filament to be able to actually get that X-ray processed through the filament circuit. And that today is going to conclude my presentation. And I thank you for watching and thank you for your time.